Far beyond the reach of the naked eye, in the vast, cold reaches of our solar system, Neptune orbits in quiet isolation. For centuries, this blue giant has been a distant enigma, its swirling clouds and mysterious storms largely concealed from view. But in recent years, with the advent of powerful new instruments like NASA's James Webb Space Telescope, the secrets of Neptune have begun to reveal themselves. And now, a monumental discovery has thrust Neptune into the spotlight. Something gigantic has just collided with the planet, and the consequences are reverberating across the cosmos. It began with an anomaly. Astronomers using the James Webb Space Telescope, or JWST, noticed unusual flashes in Neptune's upper atmosphere, brief, bright bursts of light that appeared and vanished in rapid succession. At first, these flashes seemed like a curiosity, perhaps a quirk of Neptune's notorious storms or an artifact in the data. But as the observations continued, it became clear that something extraordinary was unfolding. Accompanying the flashes was a noticeable spike in temperature. Neptune, typically one of the coldest planets in the solar system, was suddenly exhibiting regions of unexpected warmth. This was not the gradual seasonal warming that astronomers sometimes observe. It was sharp, abrupt, and localized. The atmospheric disturbances grew more pronounced, with clouds swirling in unusual patterns and shock waves rippling outward from a specific point on the planet's surface. As data poured in, a remarkable picture began to emerge. Neptune had been struck by a massive object, most likely a large body from the distant Kuiper Belt, the ring of icy debris that circles the Sun beyond Neptune's own orbit. Such collisions are rare in our solar system today, but when they do occur, they are events of staggering power. The impact itself unleashed an immense amount of energy, dwarfing even the most powerful atomic explosions ever produced on Earth. The incoming object, traveling at tens of kilometers per second, slammed into Neptune's upper atmosphere, releasing its kinetic energy in a violent burst. The heat of the collision vaporized the impactor almost instantly, sending a plume of superheated gas and debris high above the cloud tops. Shock waves raced through the atmosphere, disrupting cloud layers and mixing gases that had not interacted for centuries. For Neptune, a planet already known for its wild weather and winds that whip around its equator at supersonic speeds, the impact was a dramatic new chapter. The collision zone became a cauldron of activity. High-altitude clouds composed of methane ice crystals were shredded and reformed in new configurations. The atmospheric composition shifted, as materials from the impactor mingled with Neptune's own gases. Scientists believe that this may have temporarily altered the planet's delicate balance of methane, hydrogen, and helium, introducing exotic compounds rarely seen in the outer solar system. One of the most astonishing side effects of the collision was the formation of a temporary ring system around Neptune. Debris from the shattered impactor was caught in the planet's gravitational embrace, spreading out into a thin, shimmering disk that encircled the planet. Such rings are common around Saturn, and to a lesser extent, Jupiter and Uranus, but they are a rarity for Neptune. These ephemeral rings are likely to persist for only a short time before being swept up by the planet's gravity or dispersed into space, but their appearance offers an unprecedented opportunity for study. The effects of the impact did not stop at Neptune itself. Orbiting the planet are a collection of moons, each with its own unique story. The smaller moons, Naiad, Thalassa, and Despina, are particularly vulnerable to disturbances. Scientists speculate that the shock waves from the collision, as well as the gravitational influence of the newly formed debris ring, could have subtly altered their orbits. Tiny impacts from secondary debris might have scarred their surfaces, leaving fresh craters as evidence of the event. Triton, Neptune's largest and most intriguing moon, was also affected. This icy world, thought to be a captured object from the Kuiper Belt itself, has a thin atmosphere of nitrogen and methane. In the aftermath of the impact, sensors detected a temporary increase in atmospheric haze around Triton, likely caused by dust and gas ejected from Neptune's atmosphere and carried outward by the planet's magnetic field. For a brief moment, The sky above Triton may have glowed with the reflected light of the impact, a silent testament to the violence unfolding on its parent planet. The scientific value of this event is immense. Impacts of this scale are incredibly rare in the modern solar system, and they provide a unique window into planetary dynamics, atmospheric chemistry, and the ongoing evolution of our cosmic neighborhood. By studying the aftermath of the collision, astronomers hope to learn more about the structure and behavior of gas giant atmospheres, the composition of objects in the Kuiper Belt, and the complex gravitational interplay between planets and their moons. For planetary scientists, the event was a reminder of the solar system's dynamic nature. While the planets may appear as unchanging beacons in the night sky, they are, in fact, subject to constant change, shaped by forces both ancient and ongoing. Collisions like the one witnessed on Neptune are echoes of the solar system's violent youth, when planets and moons were regularly battered by stray objects and the architecture of our planetary system was still being carved out. The James Webb Space Telescope was not designed specifically to watch for planetary collisions, but its unmatched sensitivity and ability to observe in infrared wavelengths made it the perfect instrument for this discovery. By peering through the haze of Neptune's upper atmosphere, JWST captured the thermal signature of the impact, the chemical changes that followed, and the evolving structure of the debris ring. These observations will keep scientists busy for years to come as they sift through the data and refine their models of planetary impacts. Beyond the immediate scientific implications, the Neptune collision also inspires a sense of wonder and humility. Our solar system, for all its seeming stability, remains a place of unpredictable drama. The same celestial mechanics that keep the planets in their orderly orbits also set the stage for rare and spectacular events, reminders that we inhabit a universe still very much in motion. The collision has reignited interest in the Kuiper Belt, that distant icy realm where comets and dwarf planets roam. The object that struck Neptune was likely a wanderer from this region, its journey across the solar system spanning millions of years. Its final moments, as it plunged into Neptune's atmosphere, were witnessed not by human eyes, but by the sensitive instruments of a space telescope stationed 1,000,000 miles from Earth. Yet, thanks to this technology, we are able to reconstruct the story, to bear witness to a cosmic event that would otherwise have passed unseen. In the weeks and months ahead, astronomers around the world will continue to monitor Neptune, searching for further signs of change. Will the temporary ring system persist, or will it quickly dissipate? How long will it take for Neptune's atmosphere to return to equilibrium? Will the orbits of its moons show measurable shifts? Each new observation will add another piece to the puzzle, deepening our understanding of the forces that shape the outer solar system. For the broader public, the news of the Neptune collision serves as a powerful reminder of the importance of planetary science and space exploration. The more we learn about our neighboring worlds, the better we can appreciate the delicate balance that makes Earth unique. And as we extend our gaze outward, we are reminded that we are not passive observers, but active participants in a cosmic story still unfolding. Ultimately, the discovery of a gigantic collision on Neptune is more than just an astronomical curiosity. It is a testament to human ingenuity, the relentless drive to explore, and the ever-present possibility of the unexpected. In the darkness beyond the reach of sunlight, Neptune has become, for a brief time, the center of cosmic attention, a place where the drama of the universe plays out on a stage of swirling clouds and icy moons. As telescopes continue to scan the skies and missions venture ever farther from home, who knows what other secrets await discovery? The story of Neptune's collision is a reminder that, in the vastness of space, there is always more to see, more to learn, and more to marvel at. And as each new chapter unfolds, we are privileged to witness the ongoing dance of worlds set against the silent backdrop of the stars. Thanks for watching Space Science Made Simple.